Dear students, in the previous class, we have seen the problem when comparing hypothesis testing in two population where sigma 1 square, sigma 2 square is known. Then we have seen that the next problem, that is sigma 1 square, sigma 2 is unknown but assumed equal variance. In this class, we are going to take another category of the problem where sigma 1 square, sigma 2 square unknown but assumed unequal. What are the assumptions we are having? The samples are randomly and independently drawn. The populations are normally distributed. Population variance are unknown and assumed unequal. The population variances are assumed unequal, so a pooled variance is not appropriate. So we have to use t value with new degrees of freedom. The formula for degrees of freedom is this one, nu equal to s1 square by n1 plus s2 square by n2 whole square divided by s1 square by n1 whole square by n minus 1 plus s2 square by n2 whole square divided by n2 minus 1. The t statistics is x1 bar minus x2 bar minus the difference root of s1 square by n1 plus s2 square by n2. You see, the previous problem we have used sp square by n1 plus sp square by n2 where the variances are equal, but here it is unequal. We cannot use sp square in both the places, so we have to use only s1 square. The corresponding formula for degrees of freedom already which you have explained. We will take one sample problem, we will solve this one. The problem is arsenic concentration in public drinking water supplies is a potential health risk. An article in Arizona Republic Sunday, May 27, 2001 reported drinking water arsenic concentration in parts per billion ppb for 10 metropolitan Phoenix communities and 10 communities in rural Arizona are given in the table. Okay. We can know what is the x1 bar, that is 12.5, s1 is 7.63, x2 bar is 27.5, s2 is 15.3. We wish to determine if there is any difference in mean arsenic concentration between metropolitan Phoenix communities and communities in rural Arizona. So what are the steps in hypothesis testing? As usual, the first step is the parameter of interest or the mean arsenic concentration for the two geographic regions, say mu1 and mu2, and we are interested in determining whether mu1 minus mu2 equal to 0. So what will be our null hypothesis? Null hypothesis is mu1 minus mu2 equal to 0, otherwise mu1 equal to mu2. Alternative hypothesis is mu1 not equal to mu2 because the signs are complementary. So alpha is 5%, if it is not given we have to assume it is a 5%. The formula for test statistics is this one, T0 is x1 bar minus x2 bar root of s1 square by n1 plus s2 square by n2. So the degrees of freedom, all the data as given in the previous slide, we can supply that value s1 square, n1, s2 square, n2 and so on. So we are getting 13.2, approximately the degrees of freedom is 13. Therefore, using alpha 5%, we would reject H naught mu1 equal to mu2 if the t value, the calculated t value is greater than 2.160 or if t value is less than minus 2.160. Because these values, there are two ways we can get this value. We can refer the t table, but we can use Python also. Directly you can use the Python to get the critical value when alpha equal to 0.02, that means when the probability is 0.025, when degrees of freedom is 13. So we have done the t by using the calculated t value is minus 2.77. Obviously minus 2.77 is lying on the rejection side, so we have to reject null hypothesis. So what we are concluding, there is evidence of difference in the means. That means it is not the equal amount of arsenic is available. There is in some cities it is more, in another cities it is less. So the conclusion, because T0 minus 2.77 is less than your minus 2.160, we have to reject null hypothesis. There is a evidence to conclude that the mean arsenic concentration in the drinking water in rural Arizona is different from the arsenic concentration in metropolitan Phoenix drinking water. It is not the same. So we will use Python to solve this problem. We can see the p value as I told you, stats.t.ppf, when in the t distribution, when this area is 0.025 because a two-tailed test, when area equal to 0.025, when the degrees of freedom is 13, we are getting it as minus 2.160. So, it is a minus 2.160, our calculated t value is how much? Minus 2.77. So, minus 2.77 will be on the left hand side, obviously we have to reject it. Instead of doing that, it is very simple in Python. You take array 1 as the values which is given for metro, the another one array 2, that is call it as rural, the value is given for rural area. So, stats.t-test underscore int, call this to array metro comma rural. See, equal underscore variance, you have to type equal to false. You remember for previous one we have written as a true. Now simply write false, you will get the your t value, your p value. Obviously it is a two-tailed test. So the p value, the alpha is, it is very small, the p value is very small. So we have to reject null hypothesis. When compared to alpha, it is only 0.01. So we have to reject our null hypothesis. Now we will go to another set of problem where there is a samples are dependent. So the test means of two related populations, they are called paired sample or matched samples. So it is repeated measures, the same population we are collecting the data before and after. So we have to find, use the difference between paired sample, di is xi minus yi. So what the logic is this is say population 1, this is population, this is also population 1, same population. Before, what was the, suppose before any treatment, suppose we can see a lot of hair oil advertisements are coming. Before applying oil, what was the length of our hair? You can say some example, some values. You take some sample mean. After some time, after applying hair oil, you can see what was the, say this is x1 bar, this is y1, x bar or y bar, before and after. So we find when you plot the difference, so you take x1 from the sample 1 before, then you take y1 from the same sample because it is the dependent sample. When you plot the difference, that when you keep on collect different pair from the same sample, when you plot the difference, that will follow normal distribution. So both the populations are normally distributed. The test statistics for the mean difference is the t value with n minus 1 degrees of freedom. So here you see previously we would write x bar, here the mean of the difference, there is a d bar. D bar is nothing but you add all the difference divided by n, that is nothing but equal to x bar minus y bar. This was your assumed difference in the population. SD is for that data, for the difference the data, what was the standard deviation, the root of n. So you will get the t value. Here also see this is your left tail test, the second one is right tail test, this is two tail test. Yeah, left tail, right tail, two tail test. But only the t is d bar minus d sd root of n with n minus 1 degrees of freedom. We will take one example for dependent sample. An article in the Journal of Strain Analysis compares, that is volume 18 and number 22, compares several methods of predicting the shear strength of steel plate girders. Data for two of these methods, one method is Karlsruhe, another method is Lehigh procedures, when applied to 9 specific girders are shown in the table. I think these this is two methods are different way of measuring the shear strength. We wish to determine whether there is any difference on the average value between two methods, because the populations are same, two differences are conducted. So Karlsruhe method, Lehigh method. In Karlsruhe method this was the values, this is Lehigh method, this was the value. We are finding the differences. Look at this, here the differences are positive. There is a possibility the difference may be negative also, that will subtracted from the positive value, there is no problem. So the first step is the parameter of interest is the difference in the mean shear strength between two methods, that is the mu d, mu1 minus mu2 equal to 0, then we call it as difference equal to 0. The third step is mu d difference is not equal to 0, So, alpha equal to 5%. The test statistics is d bar divided by SD divided by root of n. It is nothing but the same thing. Previously, what was the T formula? If it is not paired sample, what was the T formula? X bar minus mu divided by S by root n. But the X bar is nothing but the mean of the difference. This is nothing but the standard deviation of the difference. This was the difference in the mean, all others are same. Because what I am saying, every statistical test has some link. Once, that is why you have to follow the order of learning this statistics, because if you in between, if you are going for some lectures, that may require certain prerequisites. So, when you learn this one, so you have to follow this sequence, so that it will be very easy for connecting with other statistical test. Okay. When you look at the table, when the alpha value is 0.025, that is half of the alpha value is 0.025, 8 degrees of freedom. So, that value is 2.3. So, if the calculated 2 value is, it is like this. So, what will you do? This value on positive side we are getting 2.306, on negative side we are getting minus 2.306. This is the value which you got from the table. The calculated t values lies on either side of this limit, it will be rejected. So, what we got, the mean of the difference is 0.2736, the standard deviation is 0.1356. When you input this data, we are getting 6.05, that is far away. So, we have to reject the null hypothesis. When you reject null hypothesis, the mu1, what was null hypothesis that? Mu1 minus mu2 equal to 0. So, H1 is mu1 minus mu2 not equal to 0. When you reject that, there is a difference. Oh, if it is an hair oil example, yes, there is a effect of hair oil that help you to grow the hair. So, we are rejecting. So, we conclude that the strength prediction method yield different result. We look at the p value, because with the help of statistical table, especially t table, finding the p value is very difficult, but we will use Python to see what is the p value. So, you take call it as array 1 call, second one Lehigh, stats dot t test, you see that this is underscore REL relative. So, that means dependent sample. So, call the two variable, you will get this is your t value, this is a p value. So, the p value is less than alpha. So, we have to reject the null hypothesis. So, that means there is a difference. Next, we will go to another problem, that is the inferences about the differences between two population proportions. So far we talk, because the population proportion means whenever there is a categorical variable is there. So far we have measured the continuous variable about from the population. If there is a categorical variable, obviously the count is taken care, that is nothing but the population proportions. So, inferences about the difference between two population proportion. So, here also we can estimate the population proportion P1 minus P2. We will do the hypothesis test about the difference of P1 minus P2. So, what is the expected value? Before going to this expected value, say this is population 1, this is population 2, I take some sample from population 1, then I am finding P1, P2, P3 and so on. I am taking some sample from this population 2. From population 2 there are different sample. If every time if I take P1 minus, that is sample which is taken from sample 1, population 1 and population 2, if I find this difference P1 minus P2, every time if I am finding P1 minus P2, so that difference if I plot that will follow normal distribution. Okay. The same logic there, if you want to know the difference of the variance, for example here what was the variance, you remember there PQ by n, sigma square is PQ by n, sigma 1 square. So, sigma 2 square is, when you call it as P1 Q1 by N1, here it is P2 Q2 by N2. If you want to know the difference in the variance, you have to add the variance. So, what will happen? P1 Q1 by N1 plus P2 Q2 by N2. This is the variance. If you want to know the standard deviation, just to take square root of that. That is why we have got this one. So, the expected value, nothing but the mean value of P1 bar minus P2 bar is, it is P1 minus P2. Standard deviation is sigma of P1 bar minus P2 is root of P1 into 1 minus P1 by N1 plus P2 into 1 minus P2 by N2. This P1 P2, you see that previously we have taken, this is nothing but the sample proportion P1, P2 also sample proportion for population 2. N1 is size of the sample taken from population 1, N2 is size of the sample taken from population 2. If the sample sizes are large, the sampling distribution of P1 bar minus P2 bar can be approximated by a normal probability distribution. The sample sizes are sufficiently large if all the conditions are met when NP is greater than or equal to 5 or NQ is greater than 5, then only we can approximate this one to the normal distribution. Okay. You see that the mean of this normal distribution is P1 minus P2, the standard deviation is root of P1 into 1 minus P1 by N1 plus P2 into 1 minus P2 by N2. The interval estimation is as usual P1 bar minus P2 bar plus or minus Z alpha by 2 root of P1 bar into 1 minus P1 by N1 plus P2 bar into 1 minus P2 by N2. If it is a single sample, you remember, can you recollect what was the formula for interval estimation? We have written it this way: P bar plus or minus Z alpha by 2 root of PQ by N. What is happening? This P is population proportion, but we have to assume, we have to approximate it with the sample proportion P1 Q1, that is small P1 Q1 by N1. So, what I am saying, everything is came from our previous single sample hypothesis testing. We will take one problem, point estimator of the difference between two population proportions. Say P1 is the proportion of population of households aware of the product after new campaign. P2 is the proportion of population of households aware of the product before new campaign. So, we are going for new promotions, we have to see the effectiveness of that promotion, advertisement. So, P1 bar is the sample proportion of households aware of the product after the new campaign. P2 is sample proportion of households aware of the product before the new campaign. So, we will find the difference. Is any impact on the campaign, new campaign on awareness. So, P1 bar minus P2 bar is, we know that P1 bar is you know that this 120 divided by 250 because it is given. So, out of 250, 120 people are aware after the campaign. So, before the campaign, out of 150, only 60 people were aware. So, the P1 bar minus P2 bar is 8%. So, hypothesis, we focus on test involving no difference between two population proportions. Here what is happening here? There also left tail test, right tail test, two tail test. Even in the two sample population proportion also, it can be left tail test, right tail test or two tail test. The standard error is root of P into 1 minus P divided by 1 by N1, 1 by N2, we have seen that one. Here also we can use pooled estimate of P when P1 and P2 equal to P. What is the meaning of this one is, if you assume that the two population proportions are same, then we can pool that. So, P bar is N1 P1 bar plus N2 P2 bar divided by N1 plus N2. Test statistics is P1 minus P2 PQ into N. So, it is the P bar into 1 minus P bar into 1 by N1 plus 1 by N2. We will take one problem, hypothesis test about P1 minus P2. Extract of St. John's wort are widely used to treat depression. This St. John's wort is a plant or medicine for treating depression. An article in April 18, 2001 issue of Journal of American Medical Association, the article title is effectiveness of St. John's Wharton major depression, a randomized control trial. Compare the efficiency of standard extract of St. John's wort with a placebo in 200 outpatients diagnosed with major depression. Patients were randomly assigned two groups. One group received the St. John's wort and other received the placebo. After 8 weeks, 19 of the placebo treated patients showed improvement, whereas 27 of those treated with St. John's wort improved. Is there any reason to believe that St. John's wort is effective curing major depression? Assume alpha equal to 5%. Okay. Now we have to see the effect of this medicine on curing the depression. The parameter of interest are P1 and P2, the proportion of patients who improve following treatment with the St. John's wort P1 or placebo. So the null hypothesis is there is no effect of this new medicine P1. So we are going to assume P1 equal to P2. Then alternative hypothesis is it is not equal to P2. Okay. It need not be two-tailed test, it is up to you to decide whether it is one tail or two-tailed test. At present we are assuming we go that there is no difference in the medicine on the improvement of the patients. The test statistics is P1 bar minus P2 bar root of P hat 1 minus P hat into 1 divided by N1 plus 1 divided by N2. So where P1 is 27 by 100, P2 19 by 100, N1 N2 is 100. So it is the pooled one. So we say since the population proportions are same, we are find out the pooled proportion 19 plus 27 plus 100 plus 100 0.23. So we have to reject our null hypothesis if it is greater than plus 1.96, otherwise less than minus 1.96. So the Z value when you substitute it is 1.35. So what is happening? 1.96 is here. So this is rejection region, our 1.35 is here, it is lying on the acceptance region. So what we are concluding, since Z0 1.35 does not exceed Z 0.025, that is 1.96, we cannot reject null hypothesis. When you look at the p value, it is 0.177. So 0.177 is more than 0.05. So we have to accept null hypothesis. There is insufficient evidence to support the claim that the St. John's wort is effective in treating major depression. So we have to accept our null hypothesis. That means there is no evidence that St. John's wort is effective. This we will do with the help of Python. You can type in Jupyter this command, then you have to verify this. Import math, we will make a function, two sample proportions P1, P2, N1, N2. First we will find out the pooled proportion. With the help of Python, we will learn how to use two sample proportion test. So import math, we define a new function 2 underscore sample underscore proportion P1, P2, N1, N2. First we will find out the pooled proportion by N1 P1 plus N2 P2 divided by N1 plus N2. We will solve with the help of Python two sample proportions hypothesis testing. So we know what is the formula, it is P1 bar minus P2 bar divided by root of PQ into 1 by N1 plus 1 by N2. First the P, we call it as a P underscore pool, is nothing but your pooled proportion P1 N1 plus P2 N2 divided by N1 plus N2. Then we will find the variance. Variance is PQ multiplied by 1 by n1 plus 1 by n2. Then we will take the square root of that will be the denominator of this formula, that is square root of x. The value of z is p1 minus p2 minus capital P1 minus capital P2 divided by root of pq into 1 by n1 plus 1 by n2. Since the value of capital P1 minus P2 whatever assumed is 0, we are not showing there. So, the z value is P1 minus P2 divided by your standard error. If the z value is less than 0, so if the z value is less than 0, we can find out the left side probability, that is nothing but our p value. If it is greater than 0, we have to subtract from 1, so you will get the p value. So, in the given problem, the P1 population proportion is 0.27, P2 population proportion is 0.19, so N1 is 100, N2 is 100. So, after getting, we are getting the z value is 1.3, so the p value is 0.17, that is more than our 0.05. So, we have to accept our null hypothesis. Since suppose if you want to know what was the z critical value, so stat non dot CDF 1.3, so where we got this 1.35, so the corresponding probability value is 0.91 from this side area is 0.91, 0. We will use Python to solve a 2 sample proportion test. We import pandas as PD, import numpy, import math. From scipy we will import stats. So, we will make a function name is 2 underscore samp underscore proportions P1, P2, N1, N2. First we will find the sample pooled proportion by using this formula N1 P1 plus N2 P2 divided by N1 plus N2. Then we will find out the variance. Variance is P into 1 minus P multiplied by 1 by N1 plus 1 by N2. So, that will be the variance. To get the standard deviation, otherwise standard error, we will take square root of our variance, that is S underscore SQ. So, Z is P1 minus P2 Z. If the Z value is less than 0, the P value from the table we can treat as it is. If the P value is positive, we have to subtract from 1. So, when you, the way we are going to call this function is by, so the function will return Z P value, that has to be multiplied by 2 because it is a 2 sample t test. So, we will run this 2 sample proportion, P1 is 0.27, P2 is 0.19, N1 is 100, N2 is 100, we will run it. So, we got the t value is 1.334, the p value is 0.17, so it is more than our alpha value. So, we have to accept null hypothesis. With this we will conclude this lecture. We will summarize this class. We have seen 2 sample hypothesis testing when sigma 1 square, sigma 2 square is unknown but not equal. Then we have seen 2 sample Z proportion test. We have taken some problems, then we have solved it. The next class we will go for comparing 2 population variance using F test.